The previous class we discussed about to calculate the packing efficiency in the FCC and BCC. We are discussed in the previous class. In this class we are going to be derive the expression to calculate the density of the unit cell. Density of the unit cell in the cubic crystal. We are going to be derive the expression. First we should let it be the edge length of the unit cell is, let it be the edge length of unit cell is A. The edge length of the unit cell is, we are going to be taken as A, and density of the solid substance is, we are going to be taken as D. Then molar mass, that is a molar mass of solid substance, we are going to be taken as capital M, that is capital M. Then the volume of the unit cell, the volume, if the edge length of the unit cell is A, then volume of unit cell is become A cube. This is the volume of the unit cell. Then mass of the unit cell is equal to, mass of unit cell is equal to, that is number of atoms into mass of each atom in unit cell. That is mass of the unit cell is equal to number of atoms and mass of each atom in unit cell. This we are going to be taken as Z into small m. The small m means mass of atom in the unit cell, means the mass of atom we are going to be taken that the mass of unit cell is equal to Z into this small m, we can be written as, the small m is equal to molar mass divided by Avogadro number. Then this small m we can be written by capital M divided by Na. Capital M is nothing but molar mass, Na is nothing but Avogadro's constant. That we know that density means the mass per unit volume. We are going to be the mass of the density of the unit cell, we can be written as density of unit cell is that is mass of unit cell divided by volume of unit cell. We know that the mass of the volume of the unit cell is A cube and mass of the unit cell is equal to this. Then we can be written as, that is Z into capital M divided by Na divided by, that is A cube. This we can be written as, that is D is equal to, that is the density of the unit cell. The density of the unit cell can be written as, that is Z into M divided by A cube into Na. This is the expression used to calculate the density of the unit cell. In these 5 parameters, if you are going to be taken density, number of atoms, molar mass, edge length, then Avogadro's number. Any 4 we know. Means we can calculate the another one parameter. Means out of these 5 parameter we should know the 4, then we can calculate the another one parameter. Now we will solve the problems regarding the density of the unit cell. When it comes to the density of the unit cell, we'll solve the problems. That is first problem. You can observe the first problem. Silver metal the crystallizes with a face centered cubic lattice, means FCC. The length of the unit cell is formed to be that is 4.077 into 10 to the power of minus 8 centimeter. Means the length of the unit cell means the edge length. They calculate the atomic radius and density of silver. They are given that atomic mass of Ag, that is 108 U, unified mass. Then they are given that is Avogadro's constant 6.023 into 10 to the power of 23 per mole. Now we are going to be taken that what they are given, means they are given the edge length. Edge length we are going to be taken as A, that is A. How much they are given? They are given the 4.077 into 10 to the power of minus 8 centimeter. We should observe the unit given, means they are given centimeter, no need of worrying. Centimeter, if they are given the edge length centimeter, meter, no need of worrying about that, as it is we can take. Then if they are given in the picometer, angstrom, nanometer, like this, we should be converter. Then that edge length they are given, that is A is equal to 4.077 into 10 to the power of minus 8 centimeter. The next FCC, number of atoms, that is Z, that is FCC number of atoms is, that is 4. FCC means number of atoms is 4. Then molar mass, that is unified mass of Ag, they are given that 108 gram per mole. M is equal to 108 gram per mole. Then the Avogadro's constant they are given, that is Na is equal to 6.023 into 10 to the power of 23 per mole. Now we know the formula, that is D is equal to, what is the formula we are going to be use? D is equal to Z into M divided by, that is A cube into Na, Avogadro's constant. Now we can be Z how much? That is 4. Molar mass is 108. Then divided by edge length is 4.077 into 10 to the power of minus 8 whole cube. Then Avogadro's constant is, that is 6.023 into 10 to the power of 23. On calculating this, we are going to be get the value, that is a 6.22 gram per cm cube. If they are given in the centimeter, we are going to take gram per centimeter. If we are going to be converted into meter, we should take the kg per meter cube unit. That is this about the this is how to calculate the density of the unit cell. There is only they asked about the density of the silver and also atomic radius. We know that for FCC, that is A is equal to 2 root 2 R. That is we should calculate the R. Then we should simplify this formula, that R is equal to A divided by 2 root 2. A is how much they are given, that is 4.077 into 10 to the power of minus 8 centimeter and divided by 2 root 2. On simplification of this, we are going to be get that 1.44 into 10 to the power of minus 8 centimeter. This about the radius. This is about the radius. This is how to solve the problem regarding the density of the unit cell. We'll see the another problem, that is we are going to be discussing an element with the density. They are given the density, that is 2.8 gram per cm cube, forms FCC unit. FCC unit means we should take the number of atoms, that is Z. Then edge length is 4 into 10 to the power of minus 8 centimeter. Calculate the molar mass of the element. Here they are given that density ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ, that is 2.8 gram per centimeter cube. Then they are given that FCC unit, then number Z is equal to 4. Then edge length they are given, A is equal to 4 into 10 to the power of minus 8 centimeter. Then we should calculate the molar mass. Then Avogadro's number they are given, that is 6.022 into 10 to the power of 23 per mole. Then you can take the formula, that is D is equal to Z into, that is a capital M, that is molar mass, divided by A cube into, that is Avogadro's constant. Then you should be rearrange this formula, that is M we should calculate, therefore the D into A cube into N A divided by Z. Then you can take that the what's the D they are given, D value, that is 2.8. The 2.8 into A cube means that is 4 into 10 to the power of minus 8 whole cube into, that is Avogadro's constant is how much they are given, that is 6.022 into 10 to the power of 23 divided by Z is nothing but 4. We are going to be get that, that is M is equal to, that is on simplification we are going to be get that 26.97 gram per mole. This is the value. On simplification of this we are going to be get that this is the value. This is about the how to calculate the molar mass if they are given the edge length, number of atoms and the Avogadro's constant. Next we will discuss another 2 problems. You can observe this copper is going to be crystallizes with the face centered cubic unit cell if the radius of copper atom, they are given, that is going to be 127.8 picometer. Then calculate the density of the copper. We should be calculated. Means here they are given the atomic mass they are given, means capital M they are given, Avogadro's constant given, we should calculate the density. Instead of giving the edge length they are given the radius they are given, means first we should find out the edge length we should find out, means FCC means for the number of atoms is equal to number of atoms, that is Z is equal to 4. Then we know that the formula, that is R is equal to, that is A we can be written as 2 root 2 R, this is the formula. Then R we can be written as A divided by 2 root 2. This we are going to be on simplification, that is we are radius they are given, how much they are given radius, that is going to be 127.8 picometer. 8 picometer they are given. Then we can be written as into 2 root 2 is equal to A. Then A is equal to, we are going to be get that the value, the A is equal to that is 127.8 into 2 root 2. We are going to be get that the value that is going to be 361.47 picometer. We are going to be get this is the value. By using this formula we can be calculate the that is the edge length. Now you can use the density formula. The density is equal to d is equal to z into m divided by a cube into n a. Z is equal to 4. Then molar mass they are given that 63.55 gram per mole divided by then A means we are going to be get the picometer. Picometer means 361.47. We should be converting into meter. We should be converting into meter means 10 to the power of minus 12. That is 361.47 into 10 to the power of minus 12 meter ಆಗುತ್ತೆ. ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ then we are going to be taken that 361.47 into 10 to the power of minus 12 whole cube into 6.02 into 10 to the power of 23 moles. Then we can be on calculating this we are going to be get the value that is going to be 8.9 gram per meter cube. This is about the density of the unit cell, that is 8.9 gram per meter cube. The next you can observe another problem. The element having the atomic mass 60 AMU, then this has FCC unit cell. The edge length of the unit cell is 4 into 10 to the power of 2 picometer. Then we should calculate the density of the unit cell. In this they are given the atomic mass, that is M. They are given the 60 AM. Then FCC unit Z is equal to 4. Then they are given the edge length A is equal to 4 into 10 to the power of 2 picometer. This we should be converting into first, that is the centimeter. We should convert into centimeter. That is going to be written that. Then density they are given Avogadro's constant. You can take the same value 6.02 into 10 to the power of 23 moles. Then D is equal to Z into M divided by A cube into N. This we should convert into centimeter. That is we are going to be written as how to convert means A is equal to 4 into 10 to the power of 2 picometer. Means this we can be written as 4 into 10 to the power of 2 into 10 to the power of minus 12 meter. Then we are going to be get that 4 into 10 to the power of minus 10 meter. Then if we are converting into meter centimeter, then we'll get that 400 into 10 to the power of minus 10 centimeter. Then we can be written as D is equal to Z means 4 into 60 divided by, that is 400 into 10 to the power of minus 10 whole cube into 6.022 into 10 to the power of 23 per moles. Then we will get that D is equal to 6.226 gram per centimeter cube. This is the unit. This is about the calculation of the that is density of the unit cells.